Hello, my name is Dmitry Mitin, and this video is a short intro to my course Introduction to Programming with Dependent Types in Scala. So, there are values and types, such values as 10, true, ABC, and types like integer, boolean, string, and we attach some type to every value. So 10 is integer, true is boolean, ABC is string, and so on. Why do we type our values? Well, we do so in order to make compiler able to perform type checking. So if our program fails, we would prefer it to fail as early as possible. For example, we would prefer if it fails in compile time rather than in runtime. So if we agree that we have two levels, level of values and level of types, then value can depend on another value. Then we have just ordinary value level function like calculating square or concatenating some string. Type can depend on another type. Then we have so-called type family, or we can call it type level function like sequence, list, array, and so on. And type can depend on value of another type. Then we have dependent type. For example, we can consider vector with 0 elements, vector of 1 element, vector of 2 elements, and so on. But not every collection will be a dependent type. Yeah, for ordinary list and sequence, array, and so on, collection of 3 elements, for example strings, sequence of 3 strings and sequence of 4 strings are values of the same type, sequence of strings. But vector of 3 strings and vector of 4 strings are values of different types. That is vector of 3 elements and vector of 4 elements. And if we try to assign value of vector of 4 elements to variable of type vector of 3 elements, then compiler doesn't allow that. That is, vector is a type where we include information about number of elements into type itself. Okay, and if we consider pair 3, that is length of our vector, and vector itself, then we have so-called dependent pair. That is a pair where second element has type depending on first element of this pair. And in some sense this is similar to point of fiber bundle in homotopy theory or differential geometry. That is, we have some base, and for every point of base we have fiber over this point. Okay. One of techniques for implementing or emulating dependent types in Scala is type level programming. That is, we can lift values to types, and then some value level calculations can be lifted to type level calculations. One more area where dependent types can be used is theorem proving. For example, here you can see proof of associativity for adding natural numbers. That is, for every natural n, m, and k, n plus m, and then plus k is the same as n plus a result of m added to k. Okay, now several words about myself. I'm an assistant professor in Department of Mathematical Analysis in Faculty of Mechanics and Mathematics in University of Kiev. And my mathematical research interests are in mathematical analysis, function theory, approximation theory, and fractal approximation. Also, I am interested in mathematical competitions for high school students and for university students. And also, I am a fan of functional programming. So now several words about how to use this course. This course is created for STEPIC contest for adaptive learning course, so you can press button continue, and then the system will try to recommend best suitable exercise personally for you. And in page with information about this course, you can find a list of all theoretical lessons, so you can look at theory lessons without recommendation system. Okay, regarding prerequisites for this course is introductory course to type theory, homotopy type theory, dependent type programming, type level programming, and theorem proving using Scala. But it's not first course in Scala, nor first course in functional programming. So some experience with Scala and some basics of functional programming is expected. Also, many exercises in this course use Proving Ground library from GitHub. So you are, in order to be able to perform tasks in this course, you're supposed to clone this repository. Okay, so if you are interested in functional programming with dependent types and type level programming, then this course is for you. Welcome and good luck.